Hello everyone. Today I will be starting with a topic that's laws of reflection, right? So light is actually a form of energy which gives us a sensation of sight. It is because of a reflection of the light which falls on our eyes and images formed we can see the objects. So before starting with the topic, I will introduce with some of the terminologies. One is luminous objects. They generate their own light, for example, the sun, the stars, the candle, the tube light, and they are illuminated objects. They reflect light. For example, the moon, the human beings, the objects around us. But there's a line of sight, a line from an object or an image to our eyes. This is important for understanding geometrical optics. So light from the object travels along this line to our eyes. You can see here a point source which emits rays of light in all the directions, and our eye receives a small portion of the light or a diverging cone of rays that's coming towards our eyes. So we receive only small diverging cone of rays. So what's actually ray of light? Why we denote light in terms of rays? Because we consider it follows a straight path. But that's not actually completely true. Whenever the obstacle is size is very small, then it bends away at the edge. That's known as diffraction. And it has a wave. It's actually an electromagnetic wave. It shows interference phenomena also. It shows polarization also. And these every phenomena give rise to important technologies that are useful to the humankind. So we need to understand each and every characteristics of light very, very minutely, very thoroughly. So there's incident ray that it is a ray that leaves the object and strikes the mirror. There's reflected ray which leaves the mirror and strikes our eyes. And the reflected ray lies along this line of sight from image to reflected ray, as we can say in the diagram. Laws of reflection. First law of reflection is angle of incidence equals angle of reflection. So we have a third line here, dashed black line. That's actually a normal, that's perpendicular to the mirror. So it is only to distinguish, it is only to specify that angle of incidence is always equal to the angle of reflection. So this is the first law of reflection. Normal is actually line perpendicular to the mirror surface. So you can see here it is dashed line. It's not actually a realistic line, but an imaginary line. So angle of incidence is angle between incident ray and the normal. Angle of reflection is angle between reflected ray and the normal. You can see here incident ray and a reflected ray, and then there's a normal perpendicular to the mirror, and angle of incidence is equal to angle of reflection. So then there is diffuse types. There are two kinds of reflection. One is diffuse reflection. That's actually specular reflection, which occurs in the mirrors when the surface is smooth. Then incident parallel rays are reflected in a parallel fashion. While as in case of diffuse, when the surface are rough surfaces, then there is diffuse reflection. That's actually for the parallel incident ray, we have unparalleled reflected rays that gives rise to diffuse reflectance. For smooth surface, it is just like mirror-like reflection. That's known as specular reflection. And diffuse reflection occurs when there are rough surfaces. So wet road glare, you can see it is very difficult, annoying to drive on a rainy day because when the oncoming vehicle at light gives us an annoying glare, that is because of this specular reflection. Because this water droplets is rainwater fills the pores and makes it a smooth surface that results in a image formation that gives us a glare. A dry asphalt road, you can see here, it gives diffuse incident light reflectance. So that's why it is easy to drive in a dry road or dry weather than in a rainy weather. So observing an image is a position in the space from which all reflected light appears to diverge. So it is actually a position in the space from which all reflected light appears to diverge. So if you see here in the object, and then there are reflected rays, why are these reflected rays actually appear to diverge? That point is an image, that's virtual image. It's actually, this light doesn't travel along this mirror, but it's actually extrapolated reflected rays that gives us a virtual image. So image formed by a plane mirror is called a virtual image. Virtual images are formed in regions where there is actually no light. The light actually does not pass through the mirror, and image is formed by extrapolated rays. That's why these are dashed lines. So you can see here a multitude of light rays from the object which are falling on a mirror. They are reflected back, but these extrapolated rays, you can see with the dashed lines, they form an image on the back side of the river of the mirror. That's actually image location. So image formed by plane mirror is virtual. Is a virtual image is actually not formed by the realistic rays, but what we see, it is upright image, and it is located as far as we are located from the mirror. Wherever our position is there, eye position is there, image also will be, virtual image will be positioned backside in same distance. So image is located as far behind the mirror as object is in front of the mirror. So how big must the mirror be if it's a plane mirror? So we see the same sized image as the size of the mirror. So you can see here man standing from, it's a plane mirror here, distance from the mirror is irrelevant if it is plane mirror. Wherever the object is there, wherever the person is there, he will see same sized image. So image that is not affected by the distance in case of plane mirror. But there are actually, if it is right angle mirror, if you place two mirrors at right angles, so you see multiple number of images, not just one, two, but you see three images also. As you tilt it away from 90 degree, then you see more images. So that happens because of multiple reflections. It is because of reflections we see the objects. So here you can see there is one object, then image one is formed by the rays which are reflected from the object. Image two is also formed by these reflected rays, and image three is also because of multiple reflections. We have a multiple image of a single object. So this is kaleidoscope. That's an instrument or toy which gives us multiple images. That's very pleasing to the sight, to the eyes. So angles smaller than 90 degrees produce more than three images. So more than three images are formed. So if we see the construction of kaleidoscope, we observe that it is actually made up of more than two rectangular mirrors, and then there are spherical mirrors which are arranged in such a way that multiple reflections occur and multiple images are formed. So in case of curved mirrors, the same law is applicable. The angle of incidence is equal to the angle of reflection. So how curved mirrors are formed? So it is actually a conversion. We can see a series of flat mirrors which are arranged in such a way that they reflect parallel raw light to a single point. They reflect a single point. That's actually a spherical mirror. So increasing the number of flat mirrors causes the shape to more closely approximate a parabola. But if we see a small portion that at the center, it more matches with that of a sphere. So parabola which is spherical close to the axis of the mirror. The parabola and the circle are almost the same shape. So at the center, if we see these parabola and circle are almost coinciding, So if we see the central part, it is just like part of a spherical mirror. So there are two kinds of curved mirrors. One is concave mirror, which is silhouetted from the inside, and one is convex, which is silhouetted from the outside. A concave mirror is silhouetted on the inside of the sphere. A concave mirror is also called a converging mirror because it converges parallel rays. A convex mirror is silhouetted on the outside of the bowl or the mirror. A convex mirror is also called a diverging mirror because it diverges parallel light. So they are both. These mirrors have a different property, different characteristics. A concave mirror is a converging mirror, whereas convex mirror is a diverging mirror. So if it converts its image formed here, you can see it's enlarged image, magnified image. In case of convex mirror, so it is for shaving or for makeup. This is useful concave mirror. In case of convex mirror, that is useful in case of at signals and traffic management, or in case of vehicles. A convex mirror is also called diverging mirror. Convex, it diverges, it gives a small image or it gives a diminished image, and also it covers a lot of area. So a lot of area covers, it gives us full view in the background if we are driving a vehicle. So concave mirror. So there's the axis which passes through the pole. There's center of curvature. There's radius of curvature. There's the radius of the sphere which forms part of this concave mirror. Then there's focus where all these parallel rays are converging. There's a focus, and there's a focal length distance from this focus to the pole of this concave mirror. So there are three useful rays. So rays parallel to the axis reflect through the focus. So these we have to remember in order to understand image formation. First is the rays parallel to the axis reflect through the focus. Parallel rays, which are incident on a concave mirror, always they reflect back through the focus. So ray through the focus reflects parallel to the axis, and if we have a ray which passes through the focus incident towards through the focus, it goes parallel. It is reflected parallel to the axis. A ray through the center of the curvature reflects back on itself, and a ray through center of curvature it's at 90 degrees to the mirror, so it is reflected back on itself. So image formation I will discuss in the next lecture. Thank you very much.